Good morning, fifth graders, and welcome to another math show with Miss Condry. Today's episode of the math show, we will be talking about something very important and foundational in math. We're going to be talking about the base 10 number system and some patterns that happen when we multiply and divide by 10 or 100 or other powers of 10. Before we get started and jump right in, though, I want to remind you that this is our classroom, and in our classroom the expectation is that we behave and act like mathematicians. So here are things that you need to keep in mind while doing math at home. Remember to have a positive attitude and to be respectful of the people helping you. Keep on trying even when it's hard, and remember that word yet. Don't forget, at any point, if something gets confusing in this video, you can always stop it and rewind it and just keep replaying it until things start to make sense. And then, of course, save those questions for me when we meet this coming week on Teams. So today's learning target is I can multiply and divide by powers of 10. The work that we're going to be talking about today is in the packet that says Unit 6, Module 1, and you'll find the work on page 205. It looks like this. All right, so our learning target is that we can multiply and divide by powers of 10. That means we need to know what powers of 10 are. Now, this is something we've talked about a lot this year in the classroom, but it's been a little bit and you're at home, so you may not remember. So I want to talk with you about what powers of 10 actually are. So earlier this year we talked about these little numbers that are called exponents, and we talked about what those numbers mean. So I've kind of written it out for you here. So when we see 10 and it has an exponent of 2, we read that 10 to the power of 2. What that means is that we're going to take 10 and we're going to multiply it by itself twice. So 10 to the power of 2 means 10 times 10. A lot of kids want to say it means 10 times 2, but that's not what it means. It means 10 by itself twice, and that will equal 100. A lot of you noticed earlier this year that when we have 10 to the power of 2, the final result also has 2 zeros as placeholders at the end. 10 to the power of 3 then is 10 times 10 times 10. So we have 3 tens multiplied by itself, and the end result is 1,000. And again, we can kind of check back and use that pattern that you noticed earlier, that when it's 10 to the power of 3, there will be 3 zeros at the end. And the pattern continues for 10 to the power of 4 and beyond. Okay, there's another thing I want to remind you of. And in our classroom, we have this big, great wall on the cupboards, and we have all of the place value words listed along with the numbers and the powers of 10. And we've used that all year to help us think about what happens when we multiply and divide by powers of 10. So I want to show you, I made one for at home to use that we're going to do today. So we've started getting into decimals this year as well. So those are part of our place value system, and numbers go forever in both directions. So we've got our ones place, our tens, hundreds. Let me use a comma to separate to the next section, and then thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, and it goes on and on forever. But then to the right of the place value, or to the right of the decimal, we also have our tenths, and that's really similar to tens, although that THS at the end reminds us that it's a fractional number, something smaller than 1. So 1/10, it can be written this way as well. Hundredths, the THS at the end signals that it's a decimal number, and thousandths, and that also goes forever in the opposite direction. Okay, I've also listed the exponents here because that's something as a fifth grader you need to also know and understand how those work. So what we're going to do today is we're going to just practice, because on the page you're going to be asked to multiply and divide by 10, 100, 1,000, 10,000. And as you do that, I want you to be accurate, and I want you to not just do something because it's a trick or because you're just seeing a pattern and just using that pattern without thinking. I want you to really know what's happening. A lot of times people say when we multiply by 10 or 100, we're adding a zero. And that, I understand what they mean, but when we add zero, that's not exactly what's happening. So I want us to really be thinking about our place value chart. We're going to start with thinking about a number. We're going to do 36 times 10. So I'm going to put 36 in its correct place value. So 36 has 6 ones and 3 tens. One of the things that you guys noticed at the beginning of the year when we made our great wall of base 10 is that every time we move to the left one place value, the numbers are multiplying by 10. So when we're multiplying by 10, we're moving to the left one place value. And likewise, when we're moving to the right, we are dividing by 10. Okay, so if I have the number 36 right here, and remember we used to do this on the cupboards in our classroom and we'd use the sticky notes, so we're going to just do a smaller version of that. If we were to multiply 36 by 10, it would get us 360. And when I write 360, it's like that 3 in the tens place. It shifts over one spot. The 6 shifts over one spot, and we get a 0 to hold the place in the ones place. That's what that adding the 0 is really referring to. It means we're putting a 0 as a placeholder because everything shifted over one spot. So now if I were to multiply by 10 again, everything is going to shift over, and we're going to need another placeholder. So the 3 in the hundreds place multiplies by 10 and becomes 1,000. 6 in the tens place multiplies by 10 and becomes hundreds. This 0 is also multiplied by 10 and it gets us 0 tens, and we need another placeholder. Okay. So what would happen if we had to multiply by not just 10, but 100? Well, one thing that we know is that 100 is 10 to the power of 2. So it means we're going to multiply by 10 and then multiply by 10 again. So if I'm going to multiply this number, 3,600, by 100, that means everything is going to multiply by 10 to the second power. So I'm going to multiply by 10, then multiply by 10 again, multiply by 10, multiply by 10 again, multiply by 10, and again, multiply by 10, and again. And now I'm going to need 2 more zeros as placeholders in the ones and in the tens place because we just multiplied by 100, or 10 to the power of 2. Okay, now let's work on dividing. Okay, if I'm going to divide by 10, the numbers shift in this direction. So everything shifts, and remember, it's not going into the negatives. A lot of times we've had discussions where we've thought maybe if we divide by 10 and there's a digit right here, that it would go into the negatives. But actually what we've discovered is that because there's place values going forever in the opposite direction, when we're dividing by 10, everything's just going to get smaller and become fractional amounts. So if I were to divide, here, I'm going to take these ones off, and we're just going to start back with our 36. Okay, if I'm going to divide by 10, then the 6 moves from the ones place to the tenths place, and now we have 6 tenths. And the 3 is also divided by 10 and moves to the ones place. So now we have 3 and 6 tenths. If I were to divide it by 100, that's 10 to the power of 2, and it would shift over 2 place values. So the 6 would divide by 10 again, because it's dividing by 100, and the 3 would divide by 10 and 10 again. And now there's nothing in the tenths place, so we need a place value holder, so we're going to put a 0 there. We would read this number as 36, and it's ending in the thousandths place, so we call it 36 thousandths. We could also put a 0 in the ones place if we wanted, and read it 0 and 36 thousandths. As you are working on this today, please remember how the digits each stay together and shift over either to the left or to the right, depending on if you're dividing or multiplying by those powers of 10. All right, good luck.